Day 463 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 231, power of 2. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given the integer n, return true if it is a power of 2, otherwise return false. An integer n is a power of 2 if there exists an integer x such that n is equal to 2 to the x power. All right, y'all, so that sounds simple enough, but let's just go ahead through these examples anyway to make sure that we are doing this problem correctly. So in example 1, we have our input n equals 1. The output is true. Explanation says because it's true because when we do 2 to the 0 power, it's going to equal 1. So anything to the 0 power is going to always be 1, and so that works for it's a power. That means 1 is a power of 2. Boom. So let's take a look at example 2. In example 2, n equals 16. The input n equals 16. The output is true. Explanation says 2 to the 4th power equals 16. So once again, 16 is a power of 2 because 2 to the 4th power will give us 16. Boom. So now let's take a look at example 3. In example 3, we have our input n equals 3. Output is false because there is no way that we could put 2 to any power and it will never equal 3. There's no power we could put to 2 that will equal 3, so our output is false. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult. It's going to be really quick. It's going to be so quick. I'm going to give y'all 2 different solutions. Guess what, y'all? And guess what? We got 2 one-liners. We got a one-liner, but we got 2 of them this time, y'all. So just stick around. Bear with me as we go through both of these one-liners because they are that simple and easy to understand. So for the first one-liner, we're going to say n is greater than 0. So we're just going to check 2 conditions. If n is greater than 0, so the power of 2 numbers is always going to be positive. So we're going to make sure that n is greater than 0. Then we're going to say and, 2 and signs. And then, so what we're going to say after that, we're going to say n and open up the parentheses, n minus 1, come outside of parentheses, we're going to say equals 0. So this is a bitwise trick, and for powers of 2, the binary representation is always going to have exactly 1, 1, right? So when I say 1, 1, I mean something like this, right? There's only 1, 1 in that binary representation. That's what I mean. And all powers of 2 are going to have exactly 1, 1. So subtracting 1 is going to flip that 1 to a 0, and that's going to turn all of the bits after it to a 1. And then anding, using the bitwise and, these 2 numbers result in 0 only for powers of 2. So that's how this part works. And yeah, that's the whole solution. So let's run it. Let's run it, y'all. Make sure it runs correctly before we submit it. Let's submit it. It's accepted. Let's see. See what the time looking like. All right, y'all. 0 milliseconds beats 100% of users with Swift. That's what I'm talking about. That's what I like to see. So now let's get into the second solution. So remember when I said that for powers of 2, the binary representation is always going to have exactly 1, 1. Well, there's an easy way to check that. We could just say n dot non-zero bit count. So this is going to count all of the bit. This is going to look at all of the. This is going to look at the bits of n. So it's going to turn into binary. It's going to look at the bits, and then we're going to see how many ones it is. So we're going to say it's equal to 1. So every non-zero bit count, remember there's only zeros and ones in binary. So this is checking for the non-zeros, right? So if there's non-zero, if there's one non-zero, that means there's only one 1, right? Going back to what I said earlier, that for powers of 2, binary representation only has exactly one 1. So this is going to turn into its binary representation, and it's going to count how many 1s there are. If there's only exactly one 1, or if that is equal to 1, then that's all we got to check. So let's run it. Make sure it runs properly before we submit it. Boom, it's accepted, so let's submit it. Now I like this solution better because it's way easier to understand. All we have to do is, once again, check how many bits are not 0, and if it's only one bit that's not 0, then we could just return true. Oh yeah, and this returns a boolean, so this right here is going to return the true or false for us. And yeah, y'all, 0 milliseconds beats 100% of users. That's what I'm talking about. Those are some good numbers right there. So we had a pretty easy problem today. We'll see what tomorrow brings. But with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.